Bismillahirrahmanirrahim. This is the fourth day class on maintenance of electrical machines. Here you have some videos which are related with maintenance. As you know, maintenance is useful in maintaining the performance of a machine or device.
Hello everybody, welcome back. Today I'm going to show you how to troubleshoot an industrial motor. And in my case, I was having like 25 kilowatt motor, and there's 400 volt, 50 hertz, and won't have.
So before you start with servicing or doing maintenance of your device, this example is related to a variable motor, and as you can see the different specifications. It has 25 kilowatts and 159 Newton meter and 400 volts, 50 hertz, 1470 revolutions per minute, and similarly the frequency ranges from 5 to 50 hertz, okay, and it can go up to 100 hertz. So this is the serial number of the motor, and the weight is 205 kgs, and similarly you can have a date here. So these details are particularly essential while you try to go for maintenance. Keep a record of that and try to note down which company, as you can see, this motor is.
1470 RPM, and its ampere rating is 45.2 amps, and IP generation is 25, and it's a tilted connection motor. And this motor actually is new, but we got several problems with this motor when it was running, and today I'm going to just show you what is the main problem and how we remove the problem. Okay, so let's start it. As you can see that my main are already trying to remove its back part, because today we're going to dismount this motor completely. You know what, sometimes it's really impossible to find out the problem for an industrial motor from outside. That's why we're trying to go inside of this motor and find out actually what happened with this motor.
So first of all you have to remove the cover to note down the details of inside.
Now we are removing its front cover from the load side, and we already put a mark on the bolt, because if there is no problem with this motor from inside, then we need to mount this motor completely, and this mark will help us to find the alignment with 4 volt from the front side.
You can see the tools that are needed for the motor.
Now we are going to release the bearing case, because the bearing case contains bearing, and of course there is a lot of grease, lubricating grease inside the bearing, and this bearing case is touched with the front cover case, so we need to remove it before you open it.
As you can see, the main problem usually with the motors is that the rotor, what you see, this device which rotates, the rotating part gets stuck up because of friction, and you need lubricating oil. Perhaps there may be no lubricating oil or grease inside, and the bearings that are there inside may have got destroyed, and then that need to be replaced. to have a better grip of the motor while you try to take out the cover, it's usually kept in on a wooden planks so that it is stable.
Okay, so these are bearing, and yeah, there's some grace this like view, and there's okay. So we thought there's a problem with bearing, but it seems like that is okay, and grease is completely new because this motor is just around like 2 3 days, and then we found a problem with this motor. And one thing is very important that the color is like black. I think it shouldn't like that because it's a new motor, and as you can see, there's a lot of carbon with the coil and of course with the rotor. I think we need to remove this back part, then we can.
So as you can see, there is a lot of problem in the rotation, and hence the grease has been what you call as dried up. So there is a need of replacing the grease and bearings.
Separate it, and we can find out actually what happened. And now we're removing this back part.
This is the removal of back part of the motor. Maria, yeah, coming up. Okay.
Okay, this is the common way in my factory we used to separate the shaft like this like old way. It seems like crazy, but you know what, it really works because this motor weight is like 205 kg, and if you wanted to remove this rotor from inside this motor, you need to push harder, and this wood is doing this.
See how pressure is applied using wood planks to remove the cover.
Yeah, for us. Backside, one side is like fuck. That means there's a problem, and look at the backside color, and it seems like okay because it's a new motor, and it should be like that. But no, motor there's a problem. Oh my god.
So you see, this is the different parts of the motor which can be inspected for repairing.
There's a metal part with this rotor, and it shouldn't supposed to stay here.
So this motor used to give a lot of screeching voice while rotating. So obviously the bearings had worn out, so that need to be replaced. So in this way, you remove the different parts and watch closely what are the different problems that are there inside the motor, and finally they get serviced. So this is the way how you repair it by opening. Next we go for another video wherein you watch the maintenance done.
GAC motor, GS5, GAC motor. आज की इस वीडियो के अंदर आप सीखेंगे कि मोटर.
So here you are learning about the different parts. You need to know about body earth testing, winding open test, resistance test. These are the three tests usually done for three-phase induction motor, and you need to prepare a checklist for doing the different tests one after another, and the different what you call as features we need to go and watch for. This is particularly the case of three-phase connection plate. I mean, the surface of the motor is put with a plate, as you have seen in the previous case, which will speak about what is the way the connection of this motor exists. So as you can see, the different ways that the motor has been connected. So obviously you have a clamp meter. This is the use of clamp meter by which you can check the windings. So as you can see, there is a beep sound included for testing. You can test for whether your device is working well. So this is testing before you actually test the motor. So for checking for the winding, this sort of test is very much useful. Connect different ends of this points, as you can see, and you have a readings on this. You can note down the readings. So this all readings have been done without giving power supply to the motor, just noting the continuity, whether existing, and is there any breakdown in the wires. So as you can see, at some point it is showing some reading and some other points it's not. So these sort of windings have some resistance. You can note down the resistance for this. So in this way you can know whether the windings of the motor are proper or not. So this is the way how you check for resistance. But different resistances can be measured. You see this reading? So in this way, by checking the resistance, this is actually the process of continuity. So next we move to the third video. Here you learn about how to use a clamp meter. This is the device. So you see the different settings on this. So this is for checking amps. It's particularly in AC, and see the ranges that you can check in. And similarly you see the resistance side, and this is for checking for beep sound continuity, and similarly this is for DC voltage and AC voltage and frequency, checking for frequency. Okay, so these are the variety of applications. Similarly, high resistance can be also checked using this device. So the best thing about this clamp meter is that you don't need probes, wires to connect. So directly by using close proximity of the meter, you can check for. So here you see the symbol denotes AC current, and this symbol represents resistance, and this diode represents continuity. When there is no break in wire, that can be checked. This is called diode continuity. Even diodes can be checked, and hence the name diode continuity. Similarly, DC voltage can be checked using this device, and AC voltage also can be checked. You can also check the AC voltage as I have said you, and finally you can also check the frequency. So these are the different ways you can check using this device. There are also special protection knobs for this device. This is called data hold knob. similarly, if you want, you can also connect probes and use this clamp device, clamp meter, just like your ordinary ammeter, voltmeter, multimeter. So for example, here you see there is a leaf wire in which the current flows. Now using the clamp meter without connecting probes, we can just find the readings of it. So here we are interested to check for AC current. Okay, so open the clamp and pass the wire in the clamp. You see the reading. So around about 1.9 amperes of current is flowing. So this is how the clamp meter can be used to check the current. You can never do a check using an ammeter directly like that. You have to connect in series. But using a clamp meter directly, you can check without opening the wire. So this is the importance of clamp meter. So very important device for testing and maintenance. Next we move to another winding control system that is used in electrical workshop. Here you have a motor and you want to test it. So as you have previously learned, there are different knobs here which can be tested. So now we are testing for the winding using a multimeter. As you see, we have kept in AC voltage and checking the different points here and measuring for. So first of all, set the knob at the desired position. Here we have the reading. So different settings, different readings can be set. So we have checked here particularly with the resistance. So maximum 200 ohms of resistance can be checked directly in this way. Here we have shorted 2 terminals. 3 terminals we have been shorted, and similarly you can take out some wires out of it and reconnect it. Mind this, we have not given power supply to the motor, and hence we are touching the knobs directly to that, or else it's not possible. So here you see the wires are pricked in and connections are made. Now you see, identify all the wires based on the circuit of the motor. And then fixed up. So this is the way how you check the 3-phase motors. Let's move to another video for winding control. So these are big motors. Here you learn about how windings can be made for connection. So these are transformer windings. So this machine directly makes the windings for a transformer. So you need to just place the wire and it does all the winding. So this is insulation that is being done for the motor, and in this way the motors can be fixed. So this is how electric motors are made. Next we move to another video for winding control system. Here you see
running RS Logics, RS Links, and RS Emulates, and someone recently asked if we could make a video on control panels that wasn't so boring. Keep in mind, this is a wastewater system, so we're representing kind of our wastewater system and showing values and various states of our boilers and pumps. If you're interested in learning more about this, just put some in the description. Maybe we'll do a video on HMIs. Got alarm silent, we got an E-stop. Make sure you use a lighted E-stop, that way we can figure out why the machine's not running. Here is your basic control panel. It has a disconnect, your power.
this is control panel, and see how we need to operate that.
But here are the wiring diagrams we use to wire this one. As you see on page C01, we have a transformer, and this is our transformer. Now our transformers are not as cool as the ones in the movies, but they're still very important and very cool, because even in North America we have varying voltages. We have 483 phase, we have 240, 3-phase 240, single phase, we have my voltmeter on 600 volts. I can test the top of this one. You see we have 480 volts. Coming out of our transformer, which is here on the bottom, we have 120 volts. So this transformer is converting 480 to 120. Similar here are two 24-volt power supplies. So here, where we took it from 480 to 120, this has 120 going into it, and check the other side, I will need to switch the DC voltage. There I have 24 volts. We use the 24 volts to power everything that is in the field. Now the field is everything external of this control panel. So all of our switches, our sensors, anything like that, anything that is out where people might touch it, will be 24 volts. Now I always say don't touch it if it's live, but 24 volt is safer than 120. Moving on to sheet D01, you will see all of our motors, and here, on and off, that's when the motor's switching on and off out in the field. I'm not going to go through every component of the wire diagram, because that would make for a very middle, and this allows it to transmit data and alarms out to the internet. These are basic circuit breakers, just like you have in your house. Motor starters, grounding, ground, 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 ground. I know it doesn't seem like that ground wire does anything but ground anyway. And if you're not sure, go ahead and ground. Here are some little miniature relays, exact same as these motor starters, except for they're just going to switch on ball or load. To make our wiring a little easier, we use rewired arms to bring all.
So you have starters here and transformer, step-up transformer, and different devices interconnected in a single panel.
Wiring here, and here, so the installer will have a point to hook all of his inputs up. Here's all our outputs. This is 4020 analog, and then what it does is it kind of reads like a tape measure. So it will fuse. While this is a little more advanced, don't let it scare you. Just look at it on our YouTube section. You'll see some videos about our analog class. We tell you what it was, but you can take any device that's general mountable. Here we're using our analog simulator. You hook the top, and it just snaps over like that. This is wire duct. Every panel needs wire duct. You have a small panel that needs wire. Have this. We would have a huge ball of nut. So it helps us keep everything tight. I hope this video has been helpful and not too boring.
So this is how you connect different devices in the single panel, and hence this is called control panel. Now you need to know what all the things that you need to have for maintenance of a transformer. First of all, a very important thing is the checking of oil level, because oil keeps on leaking and there is every chance that oil may dry up, and thereby cooling system on the transformer may become problematic. So you have to check oil and check for the temperature of the winding and see that they are replaced and maintained. Similarly, the current of the transformer need to be noted. You also need to check oil levels in the bushings. These are called bushings. You must have seen in every transformer. These sort of things do exist. They also have oil, and that also need to be checked for the minimum level. Similarly, there are different things which are useful for doing it. This is called silica gel breather. This is used for breathing holes in the transformer. Another important device is conservator system. As you can see here, you have air, you have oil, level gauges, and this is called breather. And in this way, we are able to maintain cooling system for a transformer. This is another way of cooling. Here you have fans and also the flow of oil. So this is a big transformer, and cooling is done by using this oil and fan system. Oil level indicator is having this sort of mechanism, and you have a float which will see the level of oil. You have magnets for displaying the needle, and you also have different parts in this way, and simultaneously you also have connection to alarm. So whenever the temperature goes very high, it gives alarm beep sounds. So this is another pressure relief device which is used in big transformers. You have the alarm switch here, and you have different levers, gaskets, diaphragms, and protective layers which are used for working of that. And you also have a relief device, just like a pressure cooker. You also have this sort of thing in transformer. This is sudden pressure relay section. Here we have different devices, control orifice, electrical switch, and different transformer connections, and the temperature compensator. So temperature can be checked and maintained. So here too, this is another way. Here we are using gas for this system of cooling. So you have high pressure valves and alarm system, and here we have the gas space and pressure, and here basically we use nitrogen gas for cooling. Similarly, you have different bolts in the transformer. See the tartib of what you call connecting the bolts. Okay, if it is circular, you first have to unbolt it in this fashion: 1, 2, 3, 4, just like in your car spare wheel. Similarly, non-circular, you have like this: 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10. This is a non-circular multi-bolt, and if it is square bolt, the system is 1, 2, 3, 4 in diagonal, and if it is rectangular, 1, 2, 3, 4 diagonal, then 5, 6. So this is the way how bolts can be tightened. So this helps in maintaining proper functioning of bolts. Similarly, to measure the temperature, we use an IR scan, infrared scan. So just point the IR scanner directly to the transformer. It will show you how much temperature, minimum to maximum possible. So if at all you have a problem in the transformer, you need to have different tests done. Okay, so like ultrasonic test, this is for arcing, sparking, and pump impeller check, so you can detect the fault. Similarly, you have ultrasonic test. You can check for nitrogen leakage. You have learned now how nitrogen is useful, and the leaking of the nitrogen can also be checked. Vacuum leaking can be checked. Similarly, vibration, if at all there in the transformer or in the winding of the motors, they can be checked with loose parts. You can tighten and so forth. And there are devices like vibration data logger to check for this. Similarly, the temperature can also be checked. by the different ways. Sound level, if there is a screeching voice, you can check for that. And similarly, there is also another corona bushing and lightning arresters. These are the devices here which can be checked for different problems. So all these are online tests, and offline tests are double power factor by just calculating and checking practically. Excitation current, turns ratio, these are the offline tests that you can check. So that's how you can do the maintenance of the different devices, particularly the electrical machines. So thank you.